Hello everyone. Today I am happy to be here to discuss our work on explainability features in conversational user interfaces with you. And this research was done in collaborative work with Professor Dr. Thomas Franke, Professor Dr. Christian Jetter, Leon Schmidt, and me. So imagine we would be able to meet in person today. That would be great for discussions, but in terms of orientation, possibly confusing. At least I'm often struggling to find the right direction, and university buildings are very special places when it comes to this confusion. So probably after arriving at the university, you would have found me looking for the place where we wanted to meet up. But let's imagine, luckily for me, the university was aware of people like me and installed a conversational user interface as a virtual reception where I can get help. However, when I'm asking where's the room for my workshop on user-centered artificial intelligence, the system tells me it did not understand me. And only after a series of unfortunate attempts, I hear another member of the workshop speaking with another reception QE next to me. Please show me where to find the location of workshop 2. And it works. So I'm lucky. In overall, I did not have a good experience with this so-called walk-up and use system that I use spontaneously and without any preparation time. And the given example is just one for walk-up and use systems, one case, but you can also find them in governmental buildings or hospitals, hotels, and so on. What can we do against this low usability and low satisfaction that I experience? We have different options to address this challenge, based on different psychological perspectives. First, we design a tool that allows us to receive rich feedback and over time teach us how our goals can be reached efficiently. As you can imagine, this is not applicable because we don't have the time to learn from experience. Secondly, we maybe could rely on instructions, how we should interact, so instructional psychology, and we train potential users. However, this is also not applicable since it's a spontaneously used system and we cannot have prior training for this system. Even if we could, it would be most inefficient solution because the users maybe want to use it only once or twice and not often. So the last approach, more from an engineering psychology perspective, is that we try to construct the system in a way that can be understood immediately and explanations that can be used for spontaneously interaction. Of course, this approach is specific to our use case. In other contexts for conversational user interfaces, an extensive onboarding, rich feedback may fit better, but maybe people need to understand the system completely for safety critical reasons or they have prior knowledge from similar systems, then it could be make more sense to use experience or training. But in our walk-up and use system case, we want to rely on explanations. So what we try to do is that we made a case study where we wanted to understand relevant concepts of conversational user interfaces, which we can introduce to the topic of explainability, and we conducted user workshops on this end. We wanted to compare a QE with traditional conventional contents and an explainable conversational user interface, which I will call XCUI, in the prototypical research. And we wanted to formulate design recommendations based on our research. And this process is what I want to show you briefly and how we did it. We conducted a broad task analysis to define which processes we could actually support with our QE. We concretely described elements of the QE that we wanted to include in our attempt to create an XQE. We decided which software, which services would be helpful to achieve this. We conducted another ideation workshop to explicitly design, also on the visual level, the functionalities, the desirable functionalities, and we realized it and compared the QE and the XQ with each other. So which typical tasks did we define? Like a typical reception task, giving information about schedules, helping to find directions, helping to find and understand meetings or appointments such as this workshop, or to give information regarding arrival or departure times, for example, public transport. And this allowed us, on the one hand, to introduce interactions with a short time window that is needed, other than booking a hotel room with maybe multiple steps and confirmation and pending confirmations and so on. And also this has different types of answers. So we combined it a speech interface where you can request something via voice, but we also have a visual component like a tablet or a screen, which gives back answers in different ways, like a map for directions or a table for departure times. So we then try to identify elements for the CUI that can be explained. And please notice this overview is not meant to be a theoretical background where you can orderly teach them or understand the different elements, but it is just a very practical approach to how you could understand in the process of interaction the different elements. So let's imagine somebody wants to ask for the room Ingolstadt. So we first have a speech recognition where the voice needs to be understood. That could already lead to potential errors. We have different entities in this speech that need to be recognized, like room Ingolstadt is a special entity that is relevant for the request here, and that could be imbued with explainability by showing which entities have been identified or not. We have the context, because of course context information is based on context, not on the interaction. So to make sure that the conversation is all more transparent, we could highlight which context informations are used to identify correct responses. So here position is lobby. We have the dialogue management to understand which path of the dialogue we could take. For example, there could be a probing question to understand, okay, when do you want to go to the room? Because maybe at one time we need to go a different way than now. Something is blocked. That could be an additional question, or we could say, okay, now we want to make an instruction. So you could also show this in a dialogue management to support people understanding of the conversation flow. And lastly, the most important part, to find the intent somebody has when speaking with the CUI or XCUI, and we could also show which intent has been identified to improve on the interaction performance and experience of the interaction. And then we maybe have a next request and this all starts over again. So here are different, let's say 5 key elements that we could possibly imbue explainability on. So we decided here to aim for local explanations. I don't want to go completely broad into the topic of explanations because I think it is just too much for 15 minutes, and there are many different versions of explanations and definition of what is an explanation. Actually, what we want to look at is a local explanation, because we don't want users to completely understand the system, but to support the ongoing interaction. And there are still different options, like we can show which information has been utilized, for example, the current position that somebody has, the probability of different outcomes for recognized entities from the speech recognition, for example, or recognized intents, which are more or less likely to be correct. For example, Ingolstadt or Innsbruck. We could show them and order them in ordered by likelihood, for example. And we can do something that is called contrastive or counterfactual explanations, often discussed in XCUI literature. Here, different input features and possible results are simulated and communicated. And this information indirectly informs you also about the utilized information and about other probable outcomes. Yet it is more complicated to understand. So maybe it is more applicable to explain system functionalities than to assist in a certain specific interaction that is ongoing. So with those input, we conducted another user workshop and came up with different designs that I want to show you. Here, for example, we decided to show intent alternatives for the users. So here's a question that has been asked, an answer that has been given, but also alternatives of intent like beamer setup or search restaurant that have been identified and that are ordered also by probability that the system realized or that the system calculated. Another option is the highlighting of entities. I spoke about it before. So we identify certain entities that are important for the conversation within requests, and we can highlight them and say, okay, this is the information that I have been using for the answer I'm giving you. And this is, for example, here Reparbar and Raummeterband. What you can see there at the bottom of the screen is something that we call the timeline, which I will also speak about in a few seconds. We also made a version of confidence representation that you can see up on the upper picture with different facial expressions here from the avatar, but the discussion about using avatar or not is a very big discussion, and also slight spoiler, in our user research this hasn't been recognized. You can also see that it is quite complicated to recognize, so I will leave it out for the moment and focus on the so-called timeline, where we have a context that is important, that can come from, for example, because the system just realized it, or because it is from the conversation that has been going on maybe for a certain time, and that will also show different entities but organized on a timeline, and to show which entities are still valid, which are still important for the system to find an answer. The system was enabled by using the architecture you can see on the slide, and we have not so much time left, so I would just like to highlight that we decided to use Rasa X as a service because it enabled us to utilize the most information in terms of explainability, and that was especially metrics regarding entities, probability, and so on, and intents. Let's now come shortly to the user research we conducted within this case study. We wanted to understand how the designed features affect performance and satisfaction. So we looked at the tasks that we gave to the people in the user research and user satisfaction that the participants reacted with, that they rated after each task, and we compared them between CUI and XCUI. And from a psychological view, I can also tell you results need to be treated carefully because we introduced all features that I showed you at once. There were not 5 different groups, there were just 2 groups on 2 different tasks, either with CUI or XCUI, and therefore it needs to be a little bit careful in interpreting the results. We had almost 50 participants. Here you find information regarding our sample, and we assigned them to groups because we designed 10 tasks which were alternating between CUI and XCUI, and we wanted to understand if there is an interaction between the specific task and the usage of CUI or XCUI. So we made 2 different groups, and each group either had the task with the CUI or the XCUI. And we did not expect to find something between these groups, but as I show you the results, for overall, if we put our both randomization groups together, we do not find a difference, significant difference between CUI and XCUI. Also no, really the effect sizes are small, and when we look at the groups, we start to find a few ideas of what could be going on in this prototypical user research. So there's no positive effect of XCUI over the whole sample, but we can see positive effects of XCUI in group B. So what is the difference between group A and group B? As you can see, the conclusion is not very strong. This different groups were not intended to happen. But when we were looking at the tasks, we could see that complex tasks assisted by a walk-up and use system were received better by group B than easy tasks, where complex tasks mean that multiple entities were relevant, that maybe I need to make more than just one speech, need to make different because there's a back request, while easy tasks are more like, where do I need to go, show one map, done. So more like single turn conversations. And in further questions like open text feedback, we found that the showing of intent information, intent alternatives, was received well, also for easy tasks, also from group A, but complex tasks, which we found better performance in from group B, highlighting the recognized entities, presenting them in timeline, was received better. So all in all, what we can conclude from our study and what we need to face in future research, even though we had a very limited possibility to evaluate it, we had not a valid, with time constraints, a valid evaluation of of the system, the CUI and walk-up and use systems should be able to display enough information to be useful without learning or experience. And here explanations of the interaction can help, and especially in complex tasks, maybe also can lead to higher satisfaction. And to show the recognized intents and entities are possible solutions for that. And what we need to research and what we also need to discuss further is how we make explanations fit to the task that people are confronted with. So thank you very much for your attention. Even when it's just a little case study on a very specific use case, I hope our approach of tackling explainability was interesting for you, and we can discuss the interaction between explanations and tasks in the future. Thank you very much.